Alright, here's an example of what you're going to do for your Punkin Chunkin lab. So, I'm going to make up some stuff here. So I'm going to say that I have an initial height of 1 foot 3 inches. And I'm going to make up that the time of my flight was 1.27 seconds. Okay. The distance of the launch here does not matter. You are not going to use that number right there for the experiment. That's just for me to award your points for being first, second, third place. So do not use this number in any of your calculations. Now, in order to do this problem, I need my initial height to be completely in feet, not feet and inches. So I'm going to have to change inches to feet. I do that by doing 3 inches divided by 12 inches, which will give me 0.25. So I have my initial height here is actually 1.25 feet. Okay, so make sure that you change your initial height to feet before you begin the problem. Then, the first thing you're going to have to do is find your initial upward velocity. So we're starting from that formula that we've been using over and over here. That formula that is h equals h sub 0 plus v sub 0 t minus 16 t squared. And for mine, I know that it took 1.27 seconds to hit the ground. And I know that my initial height, my h sub 0, was 1.25 feet. So to plug that in, I'm going to have h equals 1.25 plus v sub 0 t minus 16 t squared. Now, this 1.27 seconds, that is my time. So I'm going to plug that in for t. And it hit the ground, which tells me that the height was 0. So, 0 equals 1.25 plus, we do not replace v sub 0, we don't know it, and that's what we're trying to find, times 1.27 minus 16 times 1.27 squared. So, let's use our calculator to figure out what that is. You're not going to grasp this, you're solving it by hand, but you're going to probably need your calculator because the numbers are a little ugly. So 16 times 1.27 squared is 25.8064. Don't round here. So 0 equals 1.25 plus, I'm going to write this way, 1.27 times v sub 0. It's just more common to see it written that way, minus 25.8064. I'm going to combine my like terms now, so that 1.25, I'm going to subtract the 25.8064, so I get negative 24.5564, so I've got 1.27 v sub 0 minus 24.5564. And I'm going to move that to the other side, so I've got 24.5564 equals 1.27 times v sub 0, and then I will divide by 1.27 on both sides. So my v sub 0 here, I divide by 1.27, is going to give me, that shouldn't have the negative, I should have gotten rid of that. That's going to be 19.33, we'll round to 3 places here, so 336 feet per second. Okay, don't round it off too much there. Keep at least 3 places. If you keep more, that's okay. So, that initial upward velocity here is 19.336 feet per second. Make sure you put units with your answers. I will count off if you don't have those units. Okay, so this now allows us to get our equation. If you look at number 6, it says use the initial upward velocity and the initial height. So for number 6, it says to use the initial upward velocity and the initial height to create a function that models your height of your pumpkin over time. So here we just want to write ourselves an equation. So h will equal 1.25, because that's our initial height, plus 19.336 t, that's our initial upward velocity, minus 16 t squared. This is all they want for number 6. This is the equation we're going to use to answer all the other problems. So, if we go to number 7, it asks for the maximum height of the pumpkin. So we're going to go to y equals, we're going to type in 1.25 plus 19.336x minus 16x squared, and I'm going to hit zoom 6 so you can see what you probably get something that doesn't look great. You can find the answer from this, but I would like a little bit better picture. So I know for my time, which is my x, I need to start at 0. I only took a 1.27 seconds to hit the ground, so if I make it like 3 seconds, I should get a little bit prettier graph here. And we can see that looks nice there. So to find the maximum, we're going to press second trace to get to the calc menu. We're going to pick number 4. We have to move our little spider all the way to the left side of the hill. Whenever it asks for left bound there at the bottom, you've got to go to the left side of that maximum. And then you're going to go to the right after you hit enter. And then go back to the middle for your guess. And we get a maximum at 0.6042, 7.091889. So the y coordinate there is our height. That's what we're looking for. Our maximum height is 7.092 feet. Keep at least 3 decimal places for me. Make sure you put units. I will count off if you don't have those. The next question asks when our pumpkin was at 3 feet. A few of you may have some trouble with this problem if your maximum was not at least 3 feet. So if your maximum was not at least 3 feet, then you need to adjust this problem. So if your maximum is too short, change it so the problem says when did your pumpkin reach a height of 2 feet. Or if your pumpkin really didn't go far, when did your pumpkin reach a height of 1 foot. But mine is fine to use with 3 feet, and most of you should not have a problem with that. So you can leave the problem as it is if that's the case. Number 3 is going to go right here on our y2. We're going to hit graph, and that'll put us a horizontal line there at 3. We'll go second trace. This time we're looking for the intersection, number 5. So hit enter. It will always do first curve and second curve right, as long as you have just one answer in the, or just 2 equations. If you go over here, we're going to find this one right here when we hit guess and enter. So I get 1.10, well, see, that'll round up to 1.110 seconds. Okay. Now, this is only one of the times that it's 3 feet. The pumpkin is at 3 feet on the way up and on the way down. So I need to do this process again. Second trace, number 5 for intersection. First curve, second curve, just to enter. When it says guess, you need to move your little spider over here to the left side and hit enter. And this time I get 0.099 seconds. So there should be 2 answers to this problem, once on the way up, once on the way down. Again, if your pumpkin did not go at least 3 feet, change the problem so that you can still answer this part. For number 9, it asks, according to your function, what height was your pumpkin at when t equals 0.25 seconds? So for this, I'm going to use my equation, h equals 1.25 plus 19.336t minus 16t squared. And I'm just plugging in 0.25 for my t. So h will equal 1.25 plus 19.336 times 0.25 minus 16 times 0.25 squared. And I'm just going to go to my calculator. I'm going to go back to the main screen to type this in. So 1.25 plus 19.336 0.336 times 0.25 minus 16 times 0.25 squared, and I get 5.084. So my height whenever the time is 0.25 is 5.084 feet. For number 10, the question asked me what I would do what the height would be if the pumpkin had been going 15 feet per second faster. So my original problem is 1.25 plus 19.336t minus 16t squared. This time I want to add 15 feet per second to my initial velocity here. So that's going to give me 34.336t. So h equals 1.25 plus 34.336t minus 16t squared would be the equation I would use instead. I'm going to go to my y equals. I'm going to change that 19 right there to a 34, and I'm going to hit graph. Now notice that made my pumpkin go a lot higher, so I'm going to have to adjust my window. So I'm going to go and make that y max bigger, probably like 25 maybe will work. Yes, we can see the maximum well there. So I'm going to press second trace. I want the maximum, so I'll choose number 4. We'll do this just like we did the other maximum point. It's just our equation is different, so we'll get a different answer. So I go to the left side of the hill, I hit enter. I go to the right side of the hill, I hit enter. Then I go back towards the center for the guess. And I get that my maximum point now, that y coordinate, is 19.671 feet. And it makes sense that that should be higher than what you got the first time because your pumpkin is going faster. For the last one, if the initial height of your pumpkin had been 3 feet higher, how long would it take for your pumpkin to hit the ground? So again, we're going back to our original problem, 1.25 plus 19.336t minus 16t squared. And this time we're going to adjust the initial height, so we're going to add 3 to that initial height right there. So our new equation will be h equals 4.25 plus 19.336t minus 16t squared. And I'll go to y equals in my calculator. I'll make this 4.25. I will change this 34 back to the 19, and I'll hit graph. This time I'm not looking for a maximum point. I'm looking for where the pumpkin hit the ground. So I'm looking for this point right here. In fact, let me take this 3 right here out so that that's not sort of confusing us about that, where that x-axis is. I'm going to look right here where it hits the x-axis. That is a 0. So I'm going to go second trace, and I'm going to choose number 2, 0. It says left bound, so I need to go close to the point and then hit my left arrow a few times, so I'm on the left side of it. And then hit enter. When it says right bound, I have to hit the right arrow all the way until I go below the x-axis. And I'll hit enter. Then I go back towards the center there to guess. And I get a 0 of 1.398. So that would be 1.398 seconds that it would take for the pumpkin to hit the ground. So as you work on this, you may work together. You're going to turn this in at the end of class. Please make sure you put units with all of your answers. Make sure you're rounding, keeping at least 3 decimal places for everything. If you need help with the calculator, ask each other. Get somebody that knows what they're doing help. You're going to turn this in at the end of class.